Hello students, welcome to the next lecture of the Kmap. Kmap basically is the graphical representation of the variable expressions, the Boolean expression, and it is used to simplify the Boolean expression. In the last lecture, we had seen by the algebraic laws how we could solve a Boolean expression. So Kmap is the algebraic method through which we can solve the Boolean expression. A Kmap basically is a diagram made up of a number of squares, and if the number of variables in the square are let's say n, the constants that contains n variables, so the map will have 2 to the power n squares. So if we have a Boolean expression with two variables, let's say ab bar plus a bar b, so there are two variables a and b, so the Kmap will have 2 to the power 2 squares, that means 4 square. So the Kmap will be of 4 squares. Each square represents a minterm, and a 1 is written into that corresponding square for the minterm present in the Boolean expression. So for example, if there is ab bar plus a bar b, then on the place for ab bar we will mention 1, and with the expression which is not present into the Boolean, that is, let's say if ab is not present, so in the square we will mention a 0. We will see it here later. So this Kmap can be of 2 variable also, can be of 3 variable also, can be 4 variable, 5 variable, and so on. But as we increase the number of variables, the complexity will also increase. So let's talk about first the simplest Kmap, which is a 2 variable Kmap. For example, these are the expressions with 2 variables. Let's say ab bar, a bar b, a bar b bar. These are all the options of the 2 variables. So let's look at the Kmap. So this is the figure number b. This is representing the Kmap of 2 variables a and b, where 0 indicates a bar, 1 indicates b bar. So you can see here the first column is representing the value a bar, b bar, as we have 0 on both the locations. The second column is representing a b bar, as we have for a1 the true value, that is a, and in the same b bar. In the third we have this a bar b, so we have a 0, and here we have a b, and in the last we have ab for both the values of a is 1 and b is 1. So this is a Kmap with 2 variables. Now let us see with some example that how we can solve the Boolean expression using the Kmap. In the Kmap we have to go through with a process that is called looping, which is actually combining these squares. So by just combining these squares we can reduce the expression. So that is actually the simplification methods. So now let's talk about this first example. This is a b bar plus a bar b bar. Now if we'll use the simple Boolean algebraic methods, so what will be the simplification of this expression? As we can see, we can take b bar common from both the terms. This will leave the expression into a plus a bar multiplied by b bar, and this a plus a bar will be a 1, and then 1 dot b bar will be a b bar. So the final simplification value of this expression comes to be b bar. Now let us see how we can form the Kmap of this expression, and from the Kmap how we can evaluate the simplified value expression. So now let's go to the Kmap. Just remember the expression is ab bar plus a bar b bar. So this is the expression, this is the Kmap for the given this figure 3.33 where we have the Kmap, and as we have already told you that we need to mention 1 for these squares whose min terms are present into the Boolean expression. As we can say in this, we have a bar, b bar, and ab bar, 2 terms. So if we remember that this column represents A bar B bar and this column represents A B bar. So in these two columns we have mentioned 1 and other squares will have zeros. So now we need to perform the process of looping where we need to find out the adjacent ones. So we have only two adjacent ones, so we will combine them into a single loop, right? And we will represent this loop. How this loop can be represented, if you can see, in the A's column we have this as a bar and this as A. So this will become A plus A bar and will vanish. On to the other hand, we have only this B bar. So the resultant expression for this will be B bar only. Right? Let's consider the another example. Into the next example, we have A B bar plus A bar B. So remember A B bar plus A bar B. So let's see the Kmap for this figure 3.34. So we have to mention A B bar, right? So A B bar, where will be A B bar? So this is A and B bar will be this. So this is the value A B bar. So we will mention a 1 here. Next was A bar B. So A bar will get into this column and B will get into this row. So the common value, common cell is this. So we will mention a 1 into this. Now we have to perform a looping operation, that is combining, where unfortunately we do not have any loop into this. So either we don't have a vertical combination or we don't have a horizontal combination, so we cannot find any looping here. So this is the simplest form. The given expression is it is already into the simplest form, so we cannot solve it or we cannot simplify further. Okay, let's talk about the next so this is another two variable. We have three terms into this, so we need to remember A B bar plus A bar B plus A bar B bar. So let's see the K map for this. Okay, so we had A B bar. So we'll mention where is A B bar. A is this, B bar is this. So the common cell is this A B bar representing. Next is A bar B. So A is this, A bar is this, B is this. So the common cell representing, we'll mention 1. So this is 1. And the third variable was A bar B bar. So A bar is here, B bar is here. So we'll mention a 1 here. So we'll mention 3 ones in all these 3 squares. And the remaining square will contain a 0. Now the next thing is looping. So we can see that we have two loops here. These are the two adjacent ones that can be combined into one segment, and these are the two ones that can be combined into one segment. Now let's talk about that what will be the expression, what will be the resultant set. From this expression we'll have only B bar, only B bar, right? And from this expression or this loop we have only A bar. So the resultant simplified expression will be A bar plus B bar. So this is the simplification. You can also see this if you want to see how algebraically this can be solved. So you will see on to the right hand side, we will from this AB bar, from this AB bar and this A bar B bar, we can or from this let me take these two, the last two, from this and this we can take A bar common. B plus B bar will be a 1 dot A bar is again A bar. And now this is A bar plus A B bar plus A. So by the absorption you can say this will be A bar plus B bar. So we had already seen this into our Kmap. Three variable Kmap. Let's talk about the three variable Kmap. Okay, so this is the three variable Kmap. So take a deep look into this three variable Kmap, where the first row will indicate so two variables are mentioned onto one side and the third variable mentioned onto the another side. So here we'll start with the combinations. First is a bar b bar, next is a bar b, the next is the last one we'll take b a bar, and this is a and b. So this is the sequence how we used to go into the next thing. This is c bar and this is c. So we can see the combination, the first cell will have a bar, b bar and c bar. You can see a bar, b bar and c bar. Into the second we have this is a bar, b and c bar. Similarly into the third, a, b and c bar. So this way we can form our Kmap, and using this Kmap we can solve or we can simplify our expressions. So let's see for an example, if we have this expression, so how the Kmap will be represented. We have a bar, b bar, c bar obviously, so we have a 1 here. Then we have a bar, b bar and c, so a bar, b bar and c, we have a 1 here. Then we have a bar, b, c bar, so we have a bar, b and then c bar, so this is another one for this third. And for the last, a, b, c bar, so this is the a, b and c bar. For this c bar we have the 1, right? So these are the ones we will mention, and for the rest we will mention all zeros. Then comes the part of the looping. So we need to perform the looping, we need to find out the combination. So if you can see, we have one this combination and one this combination. So looping can be performed into this way. From this first looping, if we'll consider that what will be the result, so we will be having from this we'll have a c bar from the row, and from the columns the common variable is picked up. So if we'll say what is the common variable, if in this we can say this is a bar b, in this we have a bar b. So this is a bar b and this is a b, the second one is a b. So we can say here 1 and here 1 is a common, that is a b. So we have from this value we have b. And plus next, the next will be taken from this where we have a b, a b, and now the common values from the second column, we don't have any common value, so this is c bar b plus a b. So these are the examples. We can also see use Kmap to simplify. Let's pick up the first one where x is a b c bar plus a b c. So let's see the Kmap. A B C bar, so where the A B C bar column, so this is A B, this is A B and this is C bar, so this will be A B C bar column. And then next is A B C, so again A B is here and C is here, so we'll have A B C. Okay, so these are the two values that have been taken into this. And so simply we can have to form the looping. So the simple looping is created by this combination. So this is a simple looping. In the second B example, we have A bar, B bar, C bar and A, B bar, C bar. So let's see the B part. What will be the B part? Okay, so the B, in the B we have this is the B part solution where we had A bar, B bar, C bar, so this is 1, and then we have A, B bar and C bar, so this is another one. So we have a pairing here. So this is a pair combinedly. So from this we can find the solution. The common variable is picked. The common variable is a bar and c. So the solution must be a bar c. Common variable is b here in this case. So this is 0 and 0. So b bar basically, b bar and c bar. So the result should be b bar c bar. Yes, so we can see b bar c bar, right. So you can see the other examples and the Kmaps. Can verify yourself, try to form a quad octet and then simplify. Similarly, we can have a 4 variable Kmap also. We'll see the 4 variable Kmap into the next lecture. Thank you so much.